Today we are going to discuss about a problem which has been asked in Amazon, Microsoft multiple times. Okay, so the question is largest continuous sequence zero sum. So what let's see the problem description. Okay, given an array A of n integers, find the largest continuous sequence in an array which sums to 0. Okay, so if we see at the problem, it's 1, 2, minus 2, 4, minus 4 is a given example. So here 1, 2, minus 2, 4 and minus 4. So here if we see, we find this subarray. We are asked continuous sequence, which is nothing but a subarray, right? So here 2 and minus 2 sums up to 0, 4 and minus 4 sums up to 0, and this entire subarray, this one 2 minus 2, 4 minus 4 also sums up to 0, right? And we have to find the largest subarray which sums to 0. So our answer will be 2, minus 2, 4 and minus 4. This is the continuous sequence. Fine. So this can be also asked in a different way, like find the longest length, the maximum possible length of the largest continuous sequence in array which sums to 0. So we can return the length as 4 here. So it can either be asked in either find the length or the subarray itself. Okay, now let's see how we can approach this. So first we will go with the basic approach. So in naive approach, what we can say is we find all the subarrays. Like if we see 1, 2, minus 2, 4, minus 4. Here one subarray is this, the next this, 1, 2, minus 2, 1, 2, minus 2, 4, 1, 2, minus 2, 4, minus 4. This is one subarray starting with index 0, right? Now next will be 2, then 2 minus 2, 2 minus 2, 4, 2 minus 2, 4 minus 4. Then we can find with minus 2, minus 2, 4, minus 2, 4, minus 4. Similarly 4, 4 minus 4 and finally minus 4. So these are all the subarrays possible in the given array. So we find all the subarrays, and after that we find the sum in the all the subarrays, and we note down what is the largest continuous sequence which sums to 0. So if we find all the subarrays combination and then find the sum of all the individual subarray, our time complexity will be O(n) of cube. Okay, although like this works, but O(n) cube is not a very good solution approach, right? So we'll see how we can optimize this. So before seeing the optimization, we will see a approach basically. So we'll see observation here. So I'll take the same array again, 1, 2, minus 2, 4 and minus 4. Let's find the prefix sum here. Okay, so prefix sum is basically like if one is like here there is no nothing is prefixed to this index 0, right? So prefix sum of index 0 will be the index 0 element itself, but from the index 1 onwards, what it will be just this a of I and then this sum, right? So it will be 1 plus 2, 3, then 3 plus minus 2, which is 1, then 1 plus 4 minus 1 plus 4, 5, and then 5 plus minus 4, 1. So this will be our basically PF sum, right? 1, 3, 1, 5, 1. So here if we observe, this sum is 1, this sum is 1, again this is here is 1. So basically here sum is repeating. So let's say here we have some element here, and till this to this index we have sum as x. Now till this index, okay, again our sum is x. So what does this say about this particular indexed element? This says the sum in this particular subarray will definitely be 0, right? Because otherwise it cannot be x, the entire this, because if it contributes anything, it will be greater than x, right? It will never be equal to x. Either it will be greater than or less than, anything is possible, because if it is like some contributing negative, it will be less than x, otherwise it will be greater than x, but never it will be equal to x if this sum is not 0. So if this is x and this is x, so definitely this should be 0. So same we, if we apply in this scenario, here sum up to this is 1, sum up to this is 1. So definitely after this 0 index till this index, whatever element we have is contributing 0, and we can verify that here. So this is 0, 1, 2, 3, 4. So first index till second index, element contributing sum is 0. And again if we come to here, we have a sum 1 at index 0, we have sum again 1 at index 4. So what does it say? So this 1, entire this also 1, that means from index 1 till 4 is 0, right? This is the observation we can find. So we will use this concept to find the optimal approach of this solution. Okay, so let's see. So a couple of things here, we can use hash map here to approach this, where we will store the sum along with the index, so that we can find the length as well as the subarray from the array. Okay, so initially the hash map, what we can have here. So initially our sum is 0, and there is no index we have yet got, right? So we can define it as -1. We can define it to basically anything which is we can ignore, basically either it can be -1 or anything greater than the length itself. Like for example here n equal to 5, so we can take 5 here, right? Because we don't have any index here as 5. Okay, so now what we can do is we have to find the subarray, right? So what we can do is we can take the start index, end index as 0 and 0, and the length, basically max length, because we have to find the max length subarray, we can define it as -infinity. Okay, and so far the sum is 0, right? Sum equal to 0. Now we will keep on finding the sum. So let me just write it again. -2, 4, -4, along with 0, 1, 2, 3, 4. These all are the index. Okay, fine. Now we will keep on adding. So here first we are getting sum as 0 plus 1 as 1. Do we have a 1? We will check, is this sum in present in our hash map? If not, we will add it. Okay, so 1 is not there in hash map, so we will add in the hash map along with the index, which is 0, right? Now we will add again the next prefix sum we'll find, which is 3. 3 is also not there, so we will update along with the index. Now we'll come to this part, 3 plus 2, 1. This is the important part here. So here we see 1 is already there in our hash map, so that means we have already found a sum, we have found a sum which is equal to 1, which exists. That means we have a subarray with sum equal to 0, otherwise same sum would not have been possible, right? In the in this direction we are going, so same concept as here what we saw. So we again found 1, so we have a subarray with sum 0. Now what we will do is we will get the index. So this index, first we will get index is 0, and we will add a +1 here. Why +1? So let's come here. Here when we saw we got 1 at 0 index, and when we got 1 at second index again. So what we did, we found the subarray from the next index, like 0 plus 1, 1 till 2, next index, right? So it is not from that index, because that index is contributing something. It is from the next index till the index we got the same sum. That particular subarray is having 0 sum, so we will add plus 1 to our current index. Okay, so we have start index here 1, end index is obviously where we got the repeating sum. So here start index is 1, end index is 2, and here length is also, what will be our length? Length will be end index minus start index plus 1, right? So it will be 2 minus 1 plus 1 equal to 2. So which is basically, we see here 2 minus 2 have length of 2. So this 2 is definitely greater than minus infinity. So we'll update this max length as 2. Okay, now we will move forward to the next element. We will add here plus 5, 1 plus 4, 5. Now 5 is not there, we'll update here 5, 2, 3, then 5 plus minus 4, 1. We found this 1 again, it is a similar repetition. Okay, 1 we found here. Okay, previously you would have noticed here we got this index from 0, but we didn't update this index, right? So why is that? Why we didn't update this? We got 1 at 2 here, right? Second index. Why we didn't update this 0 to 2? Rather we left it there. Because of this condition, we have to find the largest subsequence, largest subarray, right? So here we found at 0 sum of 1 and at 2. So if we would have updated this 1 2 at second index, what would have happened? When we see the next one, we will now measure this to this distance, which will again be 2, but we are missing this 2, this 4, right? Means basically here, from here to here, this is 4 length. So how we would have linked up to 0th index here? That's why we didn't update. Since we have to find the largest subarray, we kept it at the smallest index which we found. Okay, so now here we found 1 again, right? So what we will do is we will follow the same. So here start index is 1, because our 1 is found at 0, 0 plus 1, 1. Now end index at 4, that is the updated index we found. Now we'll find the length, which will be 4 minus 1 plus 1, which is 4 again. So 4 is definitely greater than the max length 2, so we'll update this to 4. So we have a max length 4, array ended, right? So our answer will be A, start index till end index plus 1, so that will include the end index. So a 1 till 5, which is basically our 2 minus 2, 4 and minus 4. So this is our answer. So I hope this dry run was fine. So now we will just see at the pseudocode. Okay, so as said, we will define the start index as 0. So just write, this is the pseudocode. Our end index is also 0 initially. We are initializing all this. Max length is minus infinity. You can define like this. and hash map, as I said, we can initialize as 0 minus 1. Okay, this is the prefix sum and this is the index. So either we can define this index as -1 or anything greater than equal to length of the array. Okay, now current sum, so far, like since we have not yet started, it is 0, right? Now we will start looping through the array. Okay, so now what we will do is, first what we did, first we found the prefix sum, so we added ai to the current sum. So we will get the current sum as, we added to this, right? So plus equal, sorry, now next what we did, we added, then we checked in hash map, right? So we will do same here. If current sum, if it is not there, we added, right? So we will just check if current sum not in fm, then fm of current sum, we stored the index, right? So it will be I. Now if the sum is there, this is the main part where we are doing everything. So what we did, so if it is not there, we got this start index, okay, and this end index and the length, right? We will do same. So how we found the start index? Start index is basically where we found that sum, right, what is matching, and we found the value and we added 1, right? So before updating directly to here, we'll update inside a separate variable. So what we will do is, suppose s equal to, we'll get the current sum, okay, that the value we got. So here here we got 0 and we added +1, okay, we'll do same here, and end index equal to I, fine. Now length how we found, equal to e minus s plus 1, and we compared the length. If length is greater than max length, then we updated max length equal to length, and we updated the start index, end index as well, right? So start index will be our same, like we got that current sum +1, end index equal to I. Okay, now we will repeat this till array is completed. Okay, now at the end we will check if there is no such scenario, right? Then that means there is no like longest sum which is possible, then we can return empty. So we'll just, that means our max length would not have updated. So we can check if max length is not equal to infinity, right? Because we initialized with it. So if it is not, then we will return this start index up to end index +1. Otherwise we will return the empty array, since we didn't get the desired result. So this is our like complete code. Okay, so what is the time complexity here? Here if we see, we just loop through the array once, and other operations are just conditions, and we are doing some manipulation here, that's all. But we are going through the array only once. So our time complexity will be O of n, our space complexity will be O of 1, because we are asked to return the summary. It is like the output, desired output, so it is O of 1 only. And if we are asked to return the maximum length, we can return this maximum length here itself. So this maximum length, which we can also return. So yeah, that's all actually for this question, largest continuous sequence zero sum. Hope it is clear.
Now let's run it in interview bit and see the result by ourselves. So here, as we discussed, we will declare current sum equal to 0, max length infinity float. Okay, then a hash map, the 0 minus 1. Okay, so now the final result as well, which will be empty array, we will return this. Now we will loop over the array. Okay, for I in range length a. So for to find the prefix sum, what we did is we added the current index element to the previous sum, right? So in our case, the previous sum here is 0. So we will add it to the current indexed element. So current sum will be plus equal to a of I. Now we'll check if the current sum exists or not in hash map. Okay. Yeah, so if current sum not in FM, so it is pretty simple. Just add it. So FM of current sum equal to I. Okay. Now we are adding the index, right? So now uh, otherwise what we need to do, otherwise we will get the start index, end index, and we'll get the length, we'll compare the length, we'll get the max length array, and finally we'll get the result. So start end index will be start end. What we discussed is start will be for first we will get the that particular sum from the hash map, right? So fm dot get current sum, because it already exists, and plus 1. Okay, and end index will be I. Now we will get the length equal to e minus s plus 1. We'll check the length. Okay, if length greater than max length, we'll update the max length equal to length, and result will be a of start index to end. Okay, so is e plus 1, since we are considering end index as well. Now at the end, so we will loop over the entire array, and at the end we will just check if there is any max length or not. So if max length not equal to this, what we initialized with, then we have a result, right? Return result. Otherwise we will return empty array. Okay, let's run it. Okay, now submit. We have submitted it successfully. So that's all, folks. Thank you.